Still on chemical energetics, we're talking about energy transfer. We got to see that depending on where the heat energy is transferred to, we have two types of reactions. We have the endothermic and then the exothermic. In endothermic, heat is coming inside the system. In exothermic, heat is being lost to the surroundings. So for endothermic reactions, the surroundings become cooler. For exothermic reactions, the surroundings become hotter. So let's start with enthalpy and then enthalpy change. All chemicals contain energy known as the enthalpy. Therefore, enthalpy is the heat content or energy content of a compound. So whenever you hear the word enthalpy, we're talking about the heat or the energy content of a substance. When you take wood, wood has energy in it. That is why we can burn wood. Okay. Enthalpy depends on the physical state of a compound and varies from one compound to another. So for solids, they will contain a certain amount of heat energy. Liquids will also contain a certain amount, but they vary from substance to substance. So let's say for liquids, we can have kerosene and then water. They are going to have different energy contents. We can have wood and then diamond, both are solids, and then they are going to have different energy content. Enthalpy has a symbol H. The word enthalpy has a symbol H, and a symbol for enthalpy change is delta H, or this triangle H here, which is pronounced as delta H. When you're calculating enthalpy change, we use the formula delta H is equal to energy content of the product minus energy content of the reactant. Energy content of the product minus energy content of the reactant. So in the end, the amount of energy you're going to get in your product minus the amount of energy your reactants are having. Okay, so if we start with 100 in a certain reaction and then heat is lost to the surroundings, so at the end the product only had 40. 100 will lead us to 40. That means this reaction lost heat to the surroundings. So 40 take away 100 is going to give us negative 60. That means when the energy in the product is lesser than the energy in the reactant, that means heat was lost to the surroundings. Therefore, the reaction is exothermic. But when it's the other way around, we start with 40 and then we end with 100. That will mean we are going to take 40 away from 100 to get 60 joules, which means that this reaction ended with more energy than it started. So clearly energy was absorbed from the surroundings. Therefore, the reaction is endothermic.